point C in our titration curve is the equivalence point. And we know that it takes 14 milliliters of the sodium hydroxide to find the equivalence point. So again, we're mixing together two chemicals. Whenever you mix them together, you have to do your dilution calculation to find your new molarities. That gives us concentration of hydrochloric acid, 0.2059 molar, concentration of the sodium hydroxide, also 0.2059. These two numbers have to be the same in a one-to-one stoichiometry because we are at equivalence. That's the definition of equivalence. Now that we have our numbers, we can plug into our ice chart. Strong acid, strong base, reaction goes 100% to the product side. Cross off the water, 0 chloride. Both chemicals run out at the same time. Again, because we're at the equivalence point. And now identify what kind of chemicals you have. No more strong acid, no more strong base. All we have left is chloride, and the chloride is neutral. Remember, the equivalence point, pH, is controlled by the salt. The salt that we made, remember, we have Na plus floating around that we've been ignoring, part of that sodium hydroxide. So the sodium plus, the reason we ignored it is it's not an acid, it's not a base. The chloride is not an acid, not a base. So what we have here is find the pH of 0.2059 molar sodium chloride, and we know from what we did previously, the cation of this salt doesn't react with water, the anion of this salt does not react with water. This salt is a neutral salt, and the pH is 7.